All right, everybody, welcome to Angle Relationships, Chapter 9. Hopefully you have your name on the paper just like I do. I just put my elbow on the keyboard, and so I want to go back to the screen. All right, cool. So we've got complementary angles, and those are angles that form a perfect corner. So I think of the C in complementary and the C in corner. That's how I remember that they create that perfect 90-degree corner. So if I know they add up to 90 degrees, how can I figure out what the missing angle of Q is? So here I've got Q. I don't know what it is, but I do know what the measure of angle P is. So what I'm going to do here is put the measure of angle P plus the measure of angle Q add up to 90 degrees because it tells me that they're complementary. Now I can just substitute in what I know. And what I know is what's given. The measure of angle P is 15 degrees. And when I add that to the measure of angle Q, which is my unknown, that's going to equal 90. To get the measure of angle Q by itself, how do I do that? How do I get this by itself? Well, I can get rid of my positive 15 by subtracting it from both sides, and that's going to leave me with just the measure of angle Q equals 75 degrees. And you're probably thinking, well, why did I set up an equation? I knew I just had to do 90 minus 15. And my answer to that is that it's not always going to be that easy. And you'll see why in just a moment. Just think if we had maybe 2x here, or 7x plus 24, then we'd have to set it up and solve algebraically. So next we're going to look at supplementary angles. And I look at the S in supplementary and the S in straight line. In other words, if I were to put these two angles together, it would create a straight line. And since I know that the measure of angle M here is 120 degrees, I can use that to figure out what the measure of angle L here is, which I don't know. So again, I'm going to create an addition equation. Think about how we'd set this up. What do we know they add up to? 180. What are my two components? Well, angle M, which is 120 degrees, plus the measure of angle L, which is unknown. And then I want to get the measure of angle L by itself. So how do I do that? Well, I can subtract 120 from both sides. That leaves me with just the measure of angle L over here and 160 over on the side. And I can check my answer to make sure that's correct. If I do 120 plus 60, that does in fact give me 180. So now what you're going to do using these two examples above is set up these equations just like we did together. All right, and then after you set up the equations, you're going to solve for the complement of 65 degrees and solve for the supplement of 43 degrees. The key here is to start off thinking, what do complementary angles add up to and what do supplementary angles add up to? Next we have vertical angles. And when I hear vertical, I think of that awesome ride at Six Flags called vertical velocity, which is these two giant pillars that are across from each other. And they swing back and forth. You go super fast. I love it. So vertical means across or opposite of. And so if I'm looking at this example here with angles 1, 2, 3, and 4, angles that are across from each other or vertical are angles 1 and angles 3. So I'm going to go ahead and highlight those. And then the other form would be angles 2 and 4. Now it says here if the measure of angle 1 is 25 degrees, which I can go ahead and write right next to angle 1, then what is the measure of angle 3? Well, we found when we played that game where we moved the lines around that vertical angles have the same angle measure. And so over here, this is also going to be 25 degrees. And since we know angle 1 is 25 degrees and angle 3 is 25 degrees, we can use that information to figure out what angle 2 is and angle 4. How do we do that? Well, think about what we know. We know that these are straight lines. So if I take a look at 1 and 2 and know that they add up to 180 degrees, then I can simply just create an equation like we did above and do 25 plus what number gives me 180. When I do that, I'm going to find the measure of angle 2. And when I find that angle measure, I know that's going to be also the angle measure of angle 4. And then we have adjacent angles, angles that are next to one another. And how I remember next to is by thinking of adjacent Derulo, or Jason Derulo as you guys know him. But he always says, all I wanna do is get up next to you. He's very adamant about getting next to you. All right? That's all he wants to do 24/7. So ABC, that angle is next to DBC. They are adjacent Derulo of each other. And so they create this big angle here, ABD. Now, what do we know? Well, we know that ABD is 59 degrees, this big green angle. And then we also know that CBD is an unknown, so I can just leave that as CBD in my equation. And then finally, I know that ABD, or ABC, excuse me, is 26 degrees. So 26 plus our unknown angle equals 59 degrees. That's my equation. How do I figure out what CBD is together? Well, I have to get it by itself. Subtract both sides. Now I have the angle CBD is equal to 33 degrees. And that makes sense. If I add these two together, it should give me 59. So now what you're going to do is use this example above to complete this workshop, naming two sets of vertical angles, so angles that are across from each other. And then after you find the vertical sets, you're going to look for the adjacent angles. So what angles are right next to each other? And then what do you call these angles that are right next to each other? For example, 2 and 3, yeah, we could call them adjacent, but we could also call them something else, because guess what? They create a straight line and add up to 180. And then we've got, if the measure of angle 1 is 50 degrees, you can go ahead and write that in. Find the following. So how do you find the angle across from it? How do you find the other angles? And then provide your reasoning. Do the same thing here. Always fill in what you know to help you figure out what you don't know. And then this is putting it all together. You've got 9 example problems, which some of them might be as easy as going 72 is across from 72, or they might require a little bit more thinking and evaluating the diagram, like question 1. You got to pay really close attention at which angle is 128 degrees here and which angle is 30 degrees, which if we look closely, it's this really, really tiny one here. So how can we use that to figure out this angle in purple that we don't know? So try your best to complete this page here and then stop. Once you get to the bottom of this page, you're going to stop and you're going to look at the CC3 book lesson, which are the core problems, and we'll have videos going through each and every one of those as well. All right, so we'll come back to this packet, but first we're going to go through the core problems to be introduced to transversals, and then we'll come back here for some additional practice. Nice job so far, everybody. I really appreciate you tuning in, and keep up the great work.